Hi everybody, welcome to week 2. This week we're going to be covering sections 1.4 and 1.5 as described on our syllabus. Uh, you notice we skipped 1.3 and that is intentional. However, if you'd like and you need to maybe get some refreshers on section 1.3, if you're of course more than welcome to go ahead and review the material there. So in section 1.4 we're going to be talking about the basic rules of algebra. And these are rules that you're going to have to apply in algebra for now until you finish taking any math class. These are pretty important that you understand these and that you follow them exactly as they're defined. The first example we're going to work about is example 1, and it just talks about some of the basic terms that are used whenever we're dealing with algebraic expressions. You see in example 1 here we have 4x plus 7 plus 5x. And the first question asks, how many terms are there in the algebraic expression? So when they talk about terms, when they're asking terms, they're actually asking how many individual entities do we have in this entire expression. The way we count how many terms there are is we just simply look, each term is divided not by individual numbers or values or variables, but by plus and minus signs. So in this particular case, we see we have 1, 2, 3 terms. The first term is 4x, the second term is 7, the third term is 5x. What is the coefficient of the first term? So this is the first term. A coefficient is defined as the numeric value in front or behind, somehow associated with your unknown variable. Our unknown variable in this case is x, so we have to look to the number that's associated with that x, and it's 4. So it's 4 times x. So the coefficient in this case is 4. What is the constant term? The constant term means that it is not attached to a variable. And we see the only term in here that is not attached to a variable is the second term, and that's the number 7. And what are the like terms in the algebraic expression? So like terms is by definition terms that have the same variable to the same power. In this particular case, we have a 4x, we have no variable, and then we have a 5x. The 4x and the 5x are similar terms just because the x is to the 1 power, or there's just a regular x. So 4x and 5x are like terms in this expression. So we'll say 4x and 5x. Again, this exercise is just to help you get used to some of the terminology. Example 2, we're talking about the commutative properties of algebraic expressions. And commutative properties, what commutative means is we can put these in any order and it'll still equal the exact same thing. So we look at number A here, and right here we have y plus 6. The equivalent statement using the commutative property is going to be 6 plus y. You see, all we did here was swap the order of the y and the 6. We get the 6 in front here and the y second, and this is an equivalent statement because this is still true. This side still equals exactly this side, so it's an equivalent statement. For the second term, the second example, we see 5x. Well, the equivalent statement using the commutative property is just going to be x times 5, or x5. This may be a little bit different to look at, but it still means the same thing. In both of these cases, on the left and on the right side, our coefficient is still 5. So if I was to ask you a coefficient of this value, it would still be 5. Again, the coefficient is going to be the number or constant value associated with your variable. Example 3, write an algebraic expression equivalent to 13x plus 8 using the commutative property of addition. So in this example up here, we use the commutative property of addition. When we did that, all we did is swap the terms. The first term went second, and the second term went first. So using that property, we'll go ahead and rewrite this expression. So here we have 13x first and 8 plus 8 second. We'll go ahead and just swap that around. That'll be 8 plus 13x. Now these are still identical statements. They still equal the exact same thing, and that's exactly what we want. Again, it's just two different ways of looking at it. Now they ask us to use the commutative property of multiplication. So the only term in this expression that uses multiplication is this term, the first term, 13x. So we learn from this example that if we write 5x is equal to x5, we can do the same thing for this first term, and we get x 13 plus 8. And now what we have is we have this expression equals this expression, and this expression still equals this expression. Additionally, this expression also equals this one. So hope that helps. Go ahead and try the examples that deal with combining, or that deal with commutative property, and let me know if you have any problems.